Hi guys, welcome to another video by TechSeps.
In previous video, we explained what neural networks are and what kind of applications those have. In this TechSept, we are going to discuss layers of neural networks. A neural network is constructed from mainly three types of layers, which are input layer, hidden layers, and output layer. Data is fed into the input layer nodes after some pre-processing steps in most cases. Hidden layers help to model data between input and output using a process called training. They are hidden because the true values of their nodes are unknown in the training dataset. Output layer produces the results for given input. Also, for the future context, remember these nodes in a layer are called neurons. In addition to those mentioned main types, there are different kind of layers which differ from their functionality. In this video, let's look at dense, convolutional, pooling and dropout layers. What is a dense layer? A dense layer, which is also called a fully connected layer, is deeply connected with its preceding layers, which means the neurons of the layer are connected to every neuron of its preceding layer. This layer is the most commonly used layer in artificial neural networks. So how do dense layers work? Each neuron in a dense layer performs in a simple linear operation on its input data, followed by a nonlinear activation function. The output from each neuron is then passed to every neuron in the next layer, where the process is repeated. So what are the limitations of dense layers? One limitation of dense layers is that they can be computationally expensive, especially for large datasets or deep networks with many layers. Another limitation is that they can be prone to overfitting, where the network becomes too specialized to the training data and performs poorly on new unseen data. What is a convolutional layer? A convolutional layer is an important type of layer in a convolutional neural network. Its most common use is for detecting features in images, in which it uses a filter to scan an image a few pixels at a time and output a feature map that classifies each feature found. The mentioned filter is sometimes called as the kernel, a set of n-dimensional weights that are multiplied against the input. Filter dimension should match with the input. For example, think of a CNN, which is used to classify images which contain two-dimensional data. Then in the convolutional layer, the filter dimension should be also 2. So what includes in that filter? The filter describes the probability values that a given pattern of pixels represents a feature. Therefore, the number of filter weights, which is the size of the filter, is smaller than the input. So the multiplication performed by convolutional process is done to patches of the original two-dimensional image data. These patch sizes match the filter size. In the convolution, multiplication using the filter is performed on all data points of the image to detect features. The filter runs through the image from left to right and top to bottom, moving with the space of some number of pixels for each iteration. This is called a stride. But what happens if the filter does not fit the corners of the image? Then a process called padding can be used to extend the corner pixels of the image such that the filter always fits within the total bound of the image for a given stride. So what are the limitations of the convolutional layer? One limitation is that they might not be effective for non-grid-like data, such as graphs or sets. So the first question, what are pooling layers? Pooling layers are a type of layer in a neural network that are used to downsample the output of a previous layer. In a pooling layer, the input data is usually partitioned into non-overlapping regions and a single value is computed for each region. So how do pooling layers work? Let's look at one common pooling layer type, which is max pooling. In a max pooling layer, the input data is divided into non-overlapping regions, typically with a rectangular shape. For each region, the maximum value within that region is computed and used as the output for that region. The output values are then arranged in a new grid with reduced dimension. Other types of pooling include average pooling, where the average value within each region is used as the output, and L2 pooling, where the L2 norm of each region is used as the output. So the next question is, why do we need to use pooling layers in neural networks? Pooling layers are used to reduce the spatial dimensions of the input data, which can help to reduce the computational cost of the network and prevent overfitting. In addition, pooling can help to make the network more invariant to small translations in the input data by ensuring that the same features are detected regardless of their exact location within the input. What are dropout layers? Dropout is a regularization technique used in neural networks to prevent overfitting. Dropout layers are a type of layer that randomly drops out, that is, sets to zero, a certain proportion of the input units during the training. So how do dropout layers work? In a dropout layer, a certain proportion of the input units are randomly selected and set to zero during each training iteration. The proportion of units to be dropped out is typically specified as the hyperparameter of the network. During testing, all units are used, but their outputs are scaled by the dropout rate. So what is the reason of using dropout layers in neural networks? Dropout layers are used to prevent overfitting, which is a common problem in neural networks, where the network becomes too specialized to the training data and performs poorly on new unseen data. By randomly dropping out units during training, dropout layers force the network to learn more robust features that are less dependent on the specific input data. Okay, I hope now you have a basic understanding about dense, convolutional, pooling and dropout layers in neural networks.
If you enjoyed this excerpt, please like and share. If you have any suggestion, feedback or question, don't hesitate to comment.
We are planning to bring you more useful content from different tech fields in the future. So to stay tuned, please subscribe and hit the bell icon. See you soon.